Hi, so I'm Alvin. Today we're going to be talking about, the Mandelbrot set, more sort of introduction. Like the Mandelbrot set is a type of self-similar fractal. No, actually that's the original one. There's a family of fractals called the Mandelbrot set, and it's probably like all of the fractals which are generated like this. There's a function f of x that also has a value c that never changes. That's why it's c. Complex, c for complex, c for constant. It never changes. So z of n changes as n changes. So z of n plus 1 equals z of n to the nth to the yth power. The y is what you add after the Mandelbrot set. If you want to talk about a specific example, and then after that, you continue doing it. If it never gets out of the boundary, that is, it's in a circle with radius y, then it's in the Mandelbrot set y. If it gets out of the boundary some point, well, actually we can never get to the exact one. Well, yeah, but we could do iterations. Like here I have the first 20 iterations of the Mandelbrot set 2 and the first 10 iterations of the Mandelbrot set. The Mandelbrot set, 3. So over here, I actually got the first 23, but I got the first 24 iterations, the first 25 actually, because I also got this, commonly called iteration 0, because it's like the boundary. So over here, the iteration 0 is so big that you can't see it. Well, you know times table, right? You know what's the times table? Of course. You know what's the times table. But did you know that times tables are pretty much like characterizing and the stuff that appears in the... I'm using desk mode again. I don't know why, but it's just so helpful. Canvas is also another helpful thing. Yeah, what, times table 3? Haven't finished that. Where's the 64 times table 2? 64 times table 2. The last time I accessed that was like 6 months ago when it was almost my birthday. You know, actually you see this shape, right? You might be thinking that's just an illusion. That isn't. It's what is so pretty about mathematics. Familiar? Does that look familiar? If not, look at this. Does this shape look familiar? Yep, they're exactly the same. In the real Mandelbrot set, they're exactly the same. Now I'm going to show you some pretty good images. Cool, huh? Orange out. Fractal, so similar fractal. Very interesting. Duh, you mean you use... Oh yeah, logistic map. We'll talk about that later in the second video. So the original one is actually the first one. The original one is actually Mandelbrot set 2 because one is too boring. One is just a dot at the 0, 0 point. Or else it just explodes. Makes sense. No matter which number you choose, if it's not 0, then if you add it on, then it'll just eventually blow up. You know, huh? They have some pretty images. You know, they don't really focus on the other ones. But no one ever focuses on the Mandelbrot set 1. It's just a tiny dot. Everybody knows that. At least everybody who knows the Mandelbrot set function knows that. So, pretty interesting, huh? I have also good stuff. I'll share in the video number 2. Bye. Though I know it's a little short.